This is a look at a way that you can submit voice recordings made on your phone or your watch, submit those to the Google Natural Language API, and then get back a text transcription of the words that you are speaking and copy them to your clipboard. And I've put in some extra helpers here to try and make this as fast and easy as possible and quickly get results back onto your clipboard. And to do that, I'm using a number of really helpful tools. One of them is called Alfred, which is a brilliant productivity app for the Mac. It runs things like text expansion, but more importantly, also runs things called workflows, which allows you to string together multiple actions together. And that's what allows us to glue together an automator script, which allows us to select our recording file and then submit that to the Natural Language API using Mark Edmondson's brilliant googleLanguaR package. And then finally, we use Alfred at the end to copy the results onto our clipboard. So it's probably easiest and quickest if I demonstrate how this all works. So I type in a keyword here in my Alfred search, and then we automatically launch an automator script that takes me to the location of the recordings, and then I select the recording that I'd like to submit, which in this case is this one. I've sorted them in date order, so I submit this one. And then in the background, ffmpeg is converting the M4A file to a WAV, and you can see we've got the results already. And then we submit that WAV file to the googleLanguaR API, and we get back the results, which I'm pasting here. So you can see I've set it so that it provides me with the file name of the audio file that we submitted to the API, and then lastly the transcript of the recording. And sadly, it got the last word wrong, but I think we can forgive it in this case. So yeah, it's something that I think is super handy. So now when I'm out running or walking or anywhere, I can just record a note to myself on my Apple Watch, and then I can, as soon as that's synchronized with my Mac hard drive, I can follow this workflow to submit the audio and get those results back onto my clipboard. So in this video now, I guess I'll go into the details of exactly how everything works together in case it's helpful for anybody else. So I mentioned about Alfred, that's where we start everything. And Alfred is this automation platform, and you can build workflows, which is what is here. I'm not going to cover that in much detail. You're going to have to go off and read the documentation, I'm afraid. But here is the workflow for this particular action that we're running. And you can see it starts with a keyword, which in this case I've set to be .stt, which I type in the search box right here, and that kicks it off. And then the next step is just a call to a terminal call to automator, and then to my workflow file. So if I just have a look for my automator scripts, I have this stt file name script right here, and we'll take a look at that. All it does is it goes into the location where my recordings are stored on my Mac, which should be pretty much the same for everybody, and you can find out using a quick Google search. So I had a look on here, and it tells you that you can find them in library application support /com.apple.voice-memos, and then there should be a recordings folder within that. So this automated workflow just launches Finder to select files within that folder, and then copies the file name to the clipboard, excuse me. And then that file name is what we're going to end up submitting to our R script, and then the R script in the background is going to make a submission to the Google Natural Language API. Unfortunately, if we submit it as it is, the file name, when Automator provides back the file name to the next step of the workflow, it provides it back like this with these brackets in and these new line characters. So these little spyglass icons right here are me replacing in the results all the new line characters and the bracket new line and the close bracket new line characters and comma new line characters, just replacing those with nothing so that it collapses the string together. And then finally, I know I should be able to do this in one, but I ended up having to make another regex to get rid of, there was an additional new line left in the results, which was causing major issues. So all of that is simply to tidy up the results so that in our the string that gets passed from this bash script onto the next section is just a single line of text, a quotable line of text that we can pass in as an argument. And this is the next line right here. So query equals number 1. That just means that we're defining the query variable as the first argument passed into this script, which will be query. And then we have to make a call to the full path to our script. It's tempting to want to try just to write like this, because you can do this in terminal, but you need to call the full path to our script. And then you can see this makes a call to a text. Well, I've called it TTS. It should be STT on my hard drive. This is a speech to text script that I've written. And then we pass in the argument of query, which is the path to our file name, which we just mentioned. And then finally, I just redirect the error output to an errors file, because there was a lot of troubleshooting required to get to this. So these steps so far, just to recap, what we've done is we've initiated the workflow using STT. This bash script just launches a automator workflow to select the files. We run a couple of bits of regex on the results from automator so that we have a single line of text. And then finally, we pass that single line of text as the query argument into the call to this R script, which is done right here. And then here is the R script itself. So once you have the argument passed in, it's fairly simple. First up, I just call a few libraries that I'm going to use. I don't think I need tidyverse in this instance, but it's just a habit. I can probably delete that later. Of course, we call googleLanguageR first, stringr because I just run some tidying up on the argument, and then the sound library, which is not something I had installed previously. That's something that we need to use later in the script. So the first line, I just run authentication using my JSON service key. And then I define a variable called arg using the command args, because the file path was passed in as an argument to our bash script. And then I don't know why this is. I need to learn about it, but I found that for some reason the argument I passed in was being separated with spaces and new lines, so I got rid of those and just joined it all together as a single string within R. And the first thing that we need to do is to convert the M4A file, because the files in our Mac hard drive live as M4As, and I don't believe they can be submitted to the Google speech to text API. So we have to convert them into a WAV file, and that's what this system command right here does. It's a bit obfuscated here because of the paste not way that I'm putting it together. But if I just quickly define arg as an example of what we might pass in, and if we set the WAV file variable here, you can see that paste naught, this is the terminal command that we're providing in. So we make a call to ffmpeg. We pass in the y argument just to default to yes if it asks us to overwrite the file, and then the I flag. We pass in the location of our M4A file in this first argument right here, and then the second one is the destination file. So we're basically telling ffmpeg to convert an M4A into a WAV file and to save that WAV file as what do we call it? Recording.wav. And then, having done that, it's just one line of code in the googleLanguageR library. We just call GL speech. Using the WAV file, I specify the language as ENGB, and then I mentioned about the sound library. So that's the library that we use to call rate. So sound rate, and that returns the rate because I noticed there were errors if I didn't provide that. And finally, once we run that transcript, in fact, let's do that, you'll see that we get our result down here in the transcript. So it's the object that's returned. We just go result and then we subset to transcript and transcript. And then finally on this line right here, I call the cat command, and I've combined arg, which is the name of the file. I found it was just helpful to know which file name my results had come from, and then just the actual transcript itself. So this is all the code that runs in the R file, and from there it's super simple. This bin bash is a reminder. This is just the information that we pass into terminal. Then using our Alfred workflow, I just pass the output, so the query variable, to the clipboard, and then finally I just call a notification, and that's how it all works. So yeah, I hope maybe someone will find this of use, maybe something that can be improved. Do let me know where I've done some horrendous coding. The terminal is not a particular strength of mine, but I'm trying to learn. Thanks a lot.